This is the third in the series then of videos regarding the PID, single loop PID control of water level in a tank. Again, we are using the Easy Automation Mini PLC HMI. This happens to be the screen that is the default screen, if you will, that comes with that application, the PV application from Automation Direct. You can see here the set point, the process variable, the output variable, which is driving the pump. Again, this is our small DC pump. This is our DC motor driver with variable voltage input to it. Obviously the PLC. Then we've got, again, down here the reservoir tank and the water in the process tank, if you will, which we're trying to maintain a particular level of water. So in this particular case, again, the set point is really irrelevant. I do not have a sensor inside of here indicating the water level. So the way that I have wired it up and fooled it, if you will, I have taken a potentiometer right here going into the motor controller. The analog value, it's 10 volts here, so it splits off of the wiper of the potentiometer and goes into the analog input of the PLC. That then determines well, the differential from set point. That's really what we've got here, PV. That would be the process variable. And these are not, they don't have the right scaling factors on them at this point, but it does illustrate the PID application. At any rate, so this is, the smaller this number is the closer the process, or the smaller the error is really hit. So the process variable would be analogous to a measurement, an instrument here, a sensor, which would put out a proportional voltage, DC voltage, as a function of the level of water inside of the tank. Now you can see that this is rising up, and what we've got here is an error of 0.51, and the output voltage to the DC motor is slowly increasing due to the analog effect. And so what we're going to do is to decrease the voltage using the potentiometer, and you can see that will decrease the error, or the differential, between the set point, if you will, and the process variable coming back in. So you can see also then that the level of the output is decreasing. Now it will take a little bit of time for the level of the water to go down, but it's certainly not rising any longer. Again, we've got three drain lines, and with one's got a valve here, and this is the supply line from the DC pump. So you can see now that the water, in fact, has gone down. It's about halfway down the carton right now. And you can also see that the output level has decreased itself down to about 33. This will go down, the integral effect, the PID algorithm, because a differential is less than 0.5, we'll take it down to 0. As you can see right now, it's down to 0. There's nothing more going into the pump, and it will drain down to the level of the lower lines here. So the pump is shut off, no output to it, and the differential is less than 0.5, which is pretty much the point at which the pump turns on and starts running.